Hello everyone, myself Manan from IEEE CS. Today, we would be taking a dive into augmented reality. Now, this is the third video of the TechNiche series presented by the IEEE Computer Society VIT. Now, sit back, relax, and enjoy. So, let's begin with what's augmented reality. Okay, first of all, augmented reality is not just a technology, it's a powerful tool that has the potential to transform the way we interact with the world around us, right? So let's first of all talk about what all can we learn from this session. Like, what's the agenda? So we would be looking at the introduction, the definition of AR, how AR really works. Then we would be looking at some applications of AR, then some AR devices that are currently in the market or some upcoming devices. Then we would be looking at some key technologies that are responsible behind the working of AR. We would be looking at some real world examples, like how AR is helping us achieve some things. Then we would also be looking at challenges and the future directions of AR. And finally, we are going to conclude. So let's start with the what is really AR? What is augmented reality? So, augmented reality basically is a technology that overlays digital content such as images, videos, 3D models onto the real world, enhancing the user's perception and interaction with the physical environment. Okay, so AR seamlessly blends the virtual and real worlds, allowing users to experience and interact with digital information in real time within physical surroundings. Right. So now let's see some core principles of AR, like the basic working principles of AR. So, just to give a short form, they are like real-time interaction, contextual augmentation, spatial mapping. Okay, now let's see a little bit more like what's inside them. So, AI technology provides real-time interaction with digital content overlaid on the physical world, allowing users to engage with both simultaneously, right? And let's talk about contextual augmentation. So, what that is basically, AR enhances the user perception of reality by providing contextually relevant information, such as annotations, additional details, directions, or something related to the real world objects. Right. Now, moving on to spatial mapping. Now, what spatial mapping is, AR systems use advanced computer vision and sensor technologies to understand the user's environment. Okay. It understands the user environment, therefore mapping a virtual content accurately onto the physical space. Right. So let's move forward now. Now, a very basic thing that we all should know before we like move into the deep of AR, like what's the difference between AR, augmented reality, and VR, virtual reality, right? Because to be honest, they seem to overlap also quite a bit, but they are different apart. So what AR is, AR overlays digital content onto the real world. Okay, it overlays the digital content, right? And the next thing is users can perceive and interact with both virtual and real world elements simultaneously. So users have to perceive both virtual and real world elements. And in AR, AR enhances the user's real world experience by providing additional information of visual enhancements. Right. Now let's move on to VR. What VR does, VR immerses users in a completely virtual environment, isolating from the real world. Right. Then in VR, users can interact with and navigate only within the virtual environment. They have no perception of the real world elements. Then VR creates a simulated reality, often through the use of headsets where the real world is replaced entirely, right? Whereas like augmented reality just gives us visual enhancements. In VR, the whole real world is replaced entirely by something a simulated reality. So that's the basic difference between augmented reality and virtual reality. So now let's move on. How does AR really works? Like how what's the working? So basically we have four components of AR. So the four components of AR are cameras, then we have sensors, then we have displays, and then we have most importantly algorithms. Now let's talk about cameras. So cameras capture the real world environment and provide a live feed for the AR system to analyze and augment. Okay, now let's move on to sensors. Sensors such as GPS, accelerometers, and gyroscopes, gather data about the user's location, orientation, and movement to accurately align virtual content with the real world. Okay, now let's move on to the most important part, displays, right? So AR content is typically presented to devices like smartphone, tablets, smart glasses, or heads-up displays, allowing users to see digital overlays in the field of view, right? Now, most important, like the real working principle of AR, the algorithms. Advanced computer vision and tracking algorithms analyze the camera input and sensor data to understand the user's perspective. It recognizes objects and precisely position virtual content in the correct spatial context. Right. So let's move forward now. Now, basically, we are going to see the process of AR content and delivery. Like, what's the basic life cycle of an AR project? First of all, is the content creation. Then we have object recognition and tracking. Then the content overlay and rendering. And then finally, the user interaction. Right. Now, we also have a little bit more about them. So let's talk about content creation first. So what content creation does is AR content creation involves designing and developing virtual objects, animations, or information that will be overlaid onto the real world, right? Then the creators use 3D modeling softwares like Blender and other softwares, animation softwares, or computer vision libraries to create and optimize AR content. Then we have object recognition and tracking. So AI systems use computer vision algorithms to identify and track real-world objects or markers to anchor virtual content. The object recognition algorithm detects specific patterns, markers, or features in the real world, therefore allowing it to be precise alignment of virtual content. Right. Now we have content overlay and rendering. Once objects are recognized and tracked, AI systems overlay virtual content onto the real world in the real time. What it does is after all the objects in our surrounding it's, it has been recognized and tracked, what the algorithm makes it believe, it overlays the virtual content onto the real world in real time. The AI system renders the digital content, ensuring it matches the user's perspective and blends seamlessly with the physical environment. Right. Now let's move on to the most important part, user interaction. Now users can interact with AR by touching, gesturing, or using voice commands, triggering virtual response or additional information. And user input is captured by the sensors or touch interfaces and proceed to enable interactive experiences. Right. Now let's move forward. Now let's see the key technologies behind augmented reality, like the basic working principles behind augmented reality. First of all, we have computer vision. So we learned about this. What all are the basic technologies behind augmented reality way before also. So now let's look a bit about them in detail as well. So first of all, we have computer vision. So what computer vision is? Computer vision algorithms analyze visual data captured by the camera to understand and interpret the real world environment, right? So like a camera is going to click some photographs, okay, and the computer algorithms are going to identify and understand what the specific object or surrounding is, right? Then we move on to object recognition and tracking. Object recognition algorithm detect and identify specific objects, markers or patterns in the real world, right? To allow a system to anchor virtual content accurately without any glitches. Then we move on to spatial mapping and localization. In the case of spatial mapping and localization, spatial mapping involves creating a virtual representation of the physical environment, right? It involves a virtual representation of the physical environment by mapping the surfaces, objects, and the other spatial features. Right. Now, the next part is the sensor integration. Sensor integration, now what it does is, now air system utilize various sensors such as accelerometers, gyroscopes, and all, right, to gather data about the user's movements, orientation, and the surrounding environment. So what it does is it helps the computer vision algorithms to like anchor the virtual content accurately, right? If I move my head towards the left side, the gyroscope is going to tell the computer that the person using the AR is right now tilting his head towards the left, right? So the computer's algorithm is going to anchor the content, the virtual content, accurately in my direction. That's what sensor integration means. Now we have rendering and display. Now If we have done all the previous steps, now the final step is like giving the output to the user, right? So now AI systems render virtual content in real time, taking into account the user's perspective and the physical environment, right? Now let's move forward. Now let's see some applications of augmented reality, right? So first of all, we have retail and e-commerce. So nowadays, many of the sites like Lenskart and all are trying virtual try-on. What's basically that is you just upload a photograph and using computer vision, using computer algorithms, the product is just projected on a face, right? The product is projected on a face or a body, and then you could try on the product basically. So it's virtual try on. Then we have product visualization. It gives us a 3D object of the 3D model of the product, which we can also place in our own floor and all, right? In our own virtual environment. Then we have instant navigation as well, right? Now let's move to education and training. Now in education and training, it's a very lucrative field right now. We have interactive learning opportunities. We have simulation and trainings. We have virtual field trips as well, right? Now let's move to healthcare and medicine. In healthcare and medicine, one of the most important things we have are surgical assistants, we have medical education, and we also have rehabilitation and therapy, right? So now we have manufacturing and engineering. Now in manufacturing engineering, we have assembly and maintenance, we have design and prototyping, and we also have the option of remote collaboration. So these are some of the applications of augmented reality. Okay, now let's move forward. Now basically let's see the benefits and impacts of AI. So like in just a short form, we basically have three benefits of AI. It helps in enhancing the user experiences, right? It helps in improved efficiency and productivity, and it also can help in better decision making, right? Now let's move on to the impact of AI. What AI like impacts on our daily lives? It first of all increases customer engagement and satisfaction, right? Second, it enhances learning and the training outcomes. Food. Then it reduces errors and the operational costs. And finally, it helps in accelerated design and prototyping process. Right. Let's move forward. These are some of the augmented reality devices nowadays, which we can see very nicely. Like first example would be, I guess, the Apple iPhone, the Measure app. It's one of the great examples of augmented reality. Then we also have some rumors about uh, Google Lens, right? That's also another example. Then we guys had a game a few years back. I mean, it's still a game, but there was a trend few years back about Pokemon Go. That's still a nice example for augmented reality and many more. Now let's see what are the challenges and the future directions for augmented reality. So basically, the challenges are two types of challenges. First would be the hardware constraints. Now, right now in today's age, the augmented reality devices have to be made in a small scale so that every user can use it. Like you can't carry a whole computer, whole heavy computer with you because like you are interacting with the real environment. Okay, so we have very limited processing power. Seeing that we can't like make it very bulky, it's has less battery life, right? And third thing is it has a less field of view, right? Now let's move on to the user interface design. The basic challenges are interaction paradigms, then we have the input methods, and then we also have the visual clutter. So these are the some challenges and the future direction in which we should move in improving AI. So now let's see about the ongoing research and advancements in this, in AI. So first of all, we are seeing some hardware developments like ongoing advancements in hardware such as more powerful processors, compact sensors, and improved displays addressing the constraints of AI devices. Then second, we have user experience design. Now research focuses on developing innovative interaction techniques, gesture recognition, and natural language processing to enhance the user experience. Then there are also some researches going on tracking and mapping. Now advancement in computer vision, simultaneous localization and mapping, and sensor fusion techniques are improving object recognition, tracking, and spatial mapping capabilities, like very nicely. So now let's move on to the future trends and innovations. Right. So basically, there are three trends that I could find right now. Uh, that would be, first of all, would be wearable AR devices. Right. So nowadays, there is a huge development of lightweight, fashionable, and more immersive wearable AR devices. Just smart glasses. Right. It is a significant future trend. Like we could see, Apple just released their Apple Vision Pro. Though it's not completely an AR, it's actually a thing they like to call as mixed reality because it takes some part from VR and some part from AR. But it's still a nice future trend. Then there are some integration with AI. The integration of artificial intelligence techniques such as computer vision, machine learning, and NLP will enhance AR's capabilities, including more accuracy in object recognition, context awareness, and more intelligent interactions. Then we also have the option of cloud-based AR. Now, leveraging cloud computing for AR processing and content delivery can overcome hardware limitations and enable more complex and realistic AR experiences. Right. So now let's see what all we have learned about. I'll just give you a short recap of what we all did. Right. We talked about what really is AR, what are some of the core principles of AR, like real-time interaction, contextual augmentation, spatial mapping. Then we uh, took a slight dip in what's the difference between augmented reality and virtual reality. Then we looked how AR really works, like what are the different components of AR. Then we looked at the timeline of a AR project. Then we look at it in detail as well. Then we took a look for the key technologies behind augmented reality, like computer vision, object recognition and tracking, spatial mapping and localization, sensor integration, rendering and display, right? Then we also look at some applications of AR in various fields like retail, education, healthcare, manufacturing, engineering, right? Then we took a look at some benefits and impacts of AR. Then we also took a look at some examples of AR devices, then some challenges that the AR is currently facing, and what all research and advancements are going, keeping in mind those challenges. And finally, we took a look at some of the future trends and innovations that are going on. So it was nice talking to you all about AI devices. I hope you guys learned something from that, and hope you guys like learned a little bit from that. And I also have submitted a article with which on Medium that's going to be an IEEE CS page. You guys could really check that out. It has more information than this PPT. I could only speak this much information in this PPT. It has much more information over there. And I also have provided with some links to some documentations and all that you might want to take a look at if this field excites you. So thank you guys. It was lovely explaining or like just giving you a brief introduction about the world of AI. So thank you so much. This was Madanand Sharma signing off.